I'm going to go over the worksheet that is molarity, dilutions, and solubility practice problems so you can check your answers. Make sure that you take any quizzes or retake any quizzes on Schoology as well to check for your understanding. So the first question says, how many grams? So in order to do this, we actually have to find the number of moles first. And we're going to find the number of moles by using the equation for molarity right here. So the equation for molarity says that the molarity is equal to the moles divided by the liters of solution. So if we look at the rest of the problem, we can see that we have 800 milliliters. We're going to need to convert that to liters because our volume always has to be in liters. So I'm going to divide that by 1,000, and so that's going to go on the bottom here as 0.8 liters. And I have a molarity, so I have 0.2 moles per liter. So I'm going to go ahead and solve for this problem by multiplying both sides by 0.8 so that it cancels on the bottom on this side, and so that I'm able to find out what my number of moles is, what my x is. So I have to do 0.2 times 0.8, and that is going to be 0.16 moles. Now that I have that, I can go ahead and convert that to my grams. So I'm going to need the molar mass of aluminum hydroxide. And so I'm going to take 0.16 moles, and one mole goes on the bottom so that moles cancels out. And I'm going to put the molar mass on the top of aluminum hydroxide, which is 78 grams. So that means that I need to take the 0.16 and I need to multiply it by 78 grams. So the number of grams I'm going to need is going to be 62.4 grams of that. The next problem asks us to determine the molarity of a solution that contains 15 grams of NaCl. So the first thing we need to do is we need to find out how many moles that is, because remember, molarity is equal to the moles divided by the liters. And we have our liters already, 1.25. So I went ahead and I put that on the bottom. But in order to find the molarity, we need to figure out our number of moles first. So I'm going to take my 15 grams and I'm going to go ahead and I'm going to divide that by the molar mass of 58.44. And I'm going to get it that I have 0.26 moles of the material. So now I can divide that by 1.25, and my molarity is going to be equal to 0.21 moles per liter. That's what molarity is in. The next problem has us using the dilution equation. So I want to know how many milliliters of a solution if I want a molarity of 6.8. So that means that those two pieces go together, my unknown volume and my 6.8 molarity. And I'm going to start with 58 milliliters of a solution that is 8 moles per liter. So I'm going to solve then for my volume here by dividing both sides by 6.8. So I'm going to multiply 58 times 8 first, and I get 464. And then I'm going to divide that by the 6.8, and that means that my volume is going to be 68.24 milliliters is the amount of solution I'm going to need of a 6.8 molar solution. The next problem wants me to determine the amount of solute needed. So it's actually asking me to find this top part here that I highlighted in red. I know that I'm going to have a total 200 milliliters of solution, and I want to have a concentration of 30%. So I'm going to put my 30% here, and then I'm going to put my 200 milliliter solution, I'm going to put that right here and solve for my problem. So 30% is like doing 30 over 100, and then we simply multiply that by the 200 milliliters of solution that we want to prepare. So that would mean that we would need 60 milliliters of solute, and I put it in milliliters because instead of our grams of solution, we have milliliters of solution. So that would mean that we would have to be describing this in terms of milliliters of solute rather than grams of solute. So on the next problem, the word saturated means that it is holding as much as it possibly can at that particular temperature of the water. And so we're given one little piece of information here that 15 grams is needed to saturate 100 grams of water. So I kind of laid out what this would look like. 30 grams then would saturate 200 grams of water, and 45 grams would saturate 300 grams of water. So we want to figure out how many grams are going to be needed for 425 grams. So we can set this up as a ratio actually. If we know that 15 grams of the solid is going to need 100 grams of water, we can set that equal to an unknown number of grams of solid is going to be needed for 425 grams of water. And then to solve this, we can cross multiply. So 15 times 425 and then 100x. So we'd have 100x is equal to 15 times 425, which when I put that in my calculator, I get 6,375. Divide both sides by 100 to solve for my x. So x is going to then be 63.75 grams of solid are going to be needed for 425 grams of water. And then using this solubility, if you have 50 grams of solute dissolved in 500 grams of water, would that be saturated? So we can set it up again the same way. So again, 15 grams of solid to 100 grams of water, set equal to x grams of solid in 500 grams of water. And we can then do again our cross multiply to figure out how many grams of solid are we going to need. And when I solve for that, it turns out that I actually need 75 grams. And it says that I only have 50 grams. So no, I am not saturated. I would actually need 25 more grams to be saturated.